Hi, today's video we are looking at 13.4 inverse trig functions, and we're going to start by looking back at what we've done previously with the unit circle. You see that I have the unit circle out here, so if you don't have your unit circle out, go ahead and get it out. So go ahead and pause and get it out. So what we've done previously is using the unit circle, if I want to find the cosine value of 5 pi over 6, cosine we know is going to be referencing that x value. So when I look at my unit circle, the x coordinate is the first coordinate in all of those points there. I want to find out what is the x coordinate of the angle 5 pi over 6. So we go around our unit circle, that's in radians. I find where 5 pi over 6 is, and that's at 150 degrees, and I want the x value. We see there that the x value, the x coordinate, is a negative root 3 over 2. All right, so we move on to number 2. We want the cosine value of 7 pi over 6. So again, cosine is the x coordinate. Now we're changing the angle measure. We now want the angle of 7 pi over 6, still in radian mode, so we go around our unit circle. We find 7 pi over 6, which is at 210 degrees, and I want the x coordinate, which again is going to be a negative root 3 over 2. Next one, we want sine. Sine is the y value of 5 pi over 6. Okay, we were there already, so we know exactly where 5 pi over 6 is at that 150. If I want the sine value, I'm looking for the y value, which is 1/2. And our last one is sine, again, the y value of 7 pi over 6. Back to that 210, the y value is a negative 1/2. So we found the cosine and the sine value of those same two angles. Let's start with the cosine value. How are they related? So if I look at my cosine value here and my cosine value there, those two angles have the same exact cosine value. So we want to think about why is that? Where does that come from? We know that when we move around our unit circle, the cosine is the distance that we're moving left and right. The sine is our value going up and down. So when I look at 150, which is 5 pi over 6, and 210, 7 pi over 6, both of these are going left 3 pi over 2. So both of those angles, although they're different angles, they are going that same direction. So both go left root 3 over 2. And that's why it's negative. And that's all based on the origin. How are the sine values related? When I look at the two sine values we have, they are opposites of each other. So let's think of why that happened. If I'm looking at the sine value of 5 pi over 6, the sine value is a positive 1/2 because I'm going up 1/2. And the sine value of 210 or 7 pi over 6, I'm going down 1/2, which is why it's making it a negative 1/2. So they're both going the same distance, they're just going in different directions. So both are 1/2 away, but one goes up and one moves down. That's the difference between that positive 1/2 and that negative 1/2. So now we're going to switch gears and we're going to look into where we're going with all of this. I want to find the cosine of theta is equal to a negative root 3 over 2. What would theta be? So over here, I'm telling you which angle to go to, and you're telling me the cosine, the sine, the tangent, those values. So I'm giving you the angle, you're telling me the ratio. What we do with our inverse trig is I want to find the angle that gives me that ratio. And lucky for us, we've actually already done this. We see up here the cosine, still that x value. Which angle or angles give me the cosine value of a negative root 3 over 2? Oh, look, we did this in 1 and 2. So in 1, we found that 5 pi over 6, which is at 150 degrees. And in number 2, 7 pi over 6, which is 210 degrees. Both of those angles are going to give me that negative root 3 over 2 relationship. And a reminder what we discussed up there, they both have a negative root 3 over 2 because both angles are left root 3 over 2 from the origin. Now if I want the sine of theta, so I'm trying to find the angle that gives me a y value of a positive 1/2. So if I'm going up a positive 1/2, oh, we have that. See, we had 5 pi over 6, which is that 150. Based on the origin, if I go here, this is moving up 1/2. What other angle could it be? So I'm also looking for going up 1/2. I had 2 where I went left. There are 2 angles that are going up 1/2, which means they have the same vertical distance up. This one also is going up 1/2. So my other option here is pi over 6, which is 30 degrees. So what these inverse trig functions are doing is they are allowing us to find the angle measures given the ratio of the trig function. So instead of being given the angle and asking for the ratio, I'm giving the ratio and you're going to tell me which angle or angles have that ratio. Now, in both of those, we found out that there's always going to be 2 possible angles because there's 2 angles that are going to move left or right the same distance, 2 angles going up or down the same distance. But we've got to be careful. The measure of the angle could be a number of a coterminal angle, but we use the value that corresponds to our unit circle. For example, if our location, which we found before, was at 30 degrees here, 30 degrees is the same as 390 degrees. That's a coterminal angle. But if I'm asking you for the angle that corresponds to that ratio, we are always going to use the value that corresponds to the unit circle. So we're not going to be using any coterminal angles. We only use values in one of 2 quadrants for each of the inverse trig functions. So this is where it's going to get tricky. We learned above that there were 2 different angles that had that ratio. Only one of the answers is correct. We found that there were 2 different angles that gave us a sine of 1/2, but only one of those angles are actually the correct answer. So each time I ask you for the angle that corresponds to that ratio, although there are 2 that fit that description, only one of them is going to be the correct answer. When we look at inverse cosine, your answer is going to be one of the angles that is in quadrant 1 or 2. We will never pick the angle that is in quadrant 3 or 4. So when we looked over here, we had cosine of a negative root 3 over 2. The 2 options we had were 150 and 210. Because we're doing cosine, the answer is the angle that's either following quadrant 1 or 2, which means this one is not the right one, and this one is. 150 is going to be the angle that works, 210 is not. If we are looking at inverse sine, our answer is going to be falling in quadrant 1 and 4. We're not going to pull the answer from quadrants 2 or 3. So when we had the sine value of being 1/2, over here, the sine ones that were 1/2 were 30 and 150 because both of those were up 1/2. According to our table, we're going to choose the angle that's either in quadrant 1 or quadrant 4, which means that 150 is not the angle that's going to work. The 30-degree angle is going to work. But sine gets even more complicated than that. So we're going to put a big star by sine. When we look at sine, there's a little catch here when we look at quadrant 4. Quadrant 1 is going to be normal. We're going to label our angles 30, which is pi over 6, 45, which is pi over 4, and etc. But if your angle happens to fall in quadrant 4, you are not going to use 330. You're not going to use 315. You're not going to use 300. You're not going to use 270. When we look at our bounds here, it's between a positive 90 and a negative 90. So instead of labeling 330, I'm going to label a negative 30 degrees, which is a negative pi over 6. Instead of listing the angle of 315, my answer is going to be a negative 45, which is a negative pi over 4. Instead of negative 300, or instead of positive 300, it's negative 60, which is a negative pi over 3. And instead of 270, we're going to have a negative 90, which is a negative pi over 2. So when evaluating and solving for an unknown angle measure on the unit circle, anytime your answer is falling in quadrant 4, we're not going to use positive angles, we're going to use the negative angle equivalency. Now all that I just said for sine is going to be the exact same for tangent. Your answer is going to be one of the angles from 1 and 4, and if it happens to be an angle from quadrant 4, you have to use those negative angle measures because our bounds are from a negative 90 to a positive 90. All right, let's go ahead and turn that sheet over and do some practice problems. I'm going to clean up my unit circle here for a second. All right, so we have the cosine of theta. So what angle has a cosine value, which means an x value, of root 2 over 2? Cosine means our movement left-right. Since it's positive, it's asking which angle makes me go right root 2 over 2. If I look at my unit circle, if I'm going right, there are two places I'm going right root 2 over 2. That is at 45 degrees and at 315. If I can actually scroll up a little bit, we can have those bounds in play there. Since it's cosine, my answer has to be the angle that falls in quadrant 1 or 2. Not 3 and 4. So I know that it's not going to be 315. Instead, my answer is going to be 45 degrees, which is going to be at pi over 4. When we're doing that inverse trig, we're always going to give our answers in degrees as well as radians. We're looking for sine. Notice the notation's a little bit different. These are two different ways to write the same thing. The cosine of what angle gives me this ratio. This is, if you were to use your calculator, solving for the unknown, solving for that theta. Theta is equal to the inverse sine of 1/2. Still asking you the exact same question. So this one is saying, what angle am I going to be at if I'm going up 1/2? So if I'm going up 1/2, my options are 30 or 150. But because it's sine, it's going to be the angle that falls in quadrant 1 or quadrant 4. So I know that it can't be 150, it has to be 30. So our answers are 30 degrees, which is going to be pi over 6. Tangent, so we want tangent of a negative root 3 over 3. That's going to happen in two different spots. We see it over here on the right, it's by 330 degrees. And then we look around our circle, and it's also here at 150. So these are two places, these are the two angles that give me a negative root 3 over 3 tangent value. We look back at our bounds for tangent. Tangent's going to be the angle that falls in quadrant 1 or quadrant 4, which means 150 degrees is not going to work. I've got to choose that 330 degree angle. But we have to be careful because anything that falls in that quadrant 4, we have to use negative angle measures. So although it is at 330 degrees, the proper way to write that is negative 30 degrees. Instead of 11 pi over 6, we write a negative pi over 6. Always making sure that we're using those correct bounds. So cosine, again, we're looking at the x value. If we're looking at the x value of a negative root 3 over 2, that means I'm looking, where am I going left? Root 3 over 2, the x coordinate. That happens in two spots, at 150 and at 210. But when I look at the cosine restrictions, it has to be quadrant 1 or 2, which means 210 is not my option. it's going to be at 150, which is 5 pi over 6. Then we've got tangent inverse of -1. What angle is that? So where do I get a -1 tangent value? We go around our unit circle. Here's a tangent of -1 at 135. And here's a tangent of -1 at 7 pi over 4. For a tangent, it has to be quadrant 1 or 4, which means 135, not my answer. Again, I'm not going to write 315. I'm going to write a -45 degrees and a negative pi over 4. Our last one for this section, sine, that's our y value. Which angle gives us a y value means that we're moving down root 2 over 2. So we're talking about our movement down. I'm going down root 2 over 2, I'm at 315. Down root 2 over 2, I'm at 225. According to my sine restrictions, I'm going to pick the angle that's in 1 or 4, which means I'm at 315 degrees. Again, we're not going to write 315, we're going to write a -45 and a negative pi over 4. For this next section, you're going to need to have your calculators out. We're going to see how to evaluate these numbers if they're not on the unit circle. So the unit circle is a certain set of values, 30 degrees, 45 degrees, 60 degrees. But what if I have 58 degrees? What if I have 43 degrees? So we're going to be able to use our calculator to find estimated answers for values that are not on the unit circle. So I'm still finding the angle measure. And because I'm solving for the angle measure, we have to use inverse trig. So here's a notation that you saw before. To isolate that theta, theta is equal to the inverse cosine of that given ratio of 0.4531. We want to give our answers in both degrees and radians, so we've got to be very, very careful about what we have in our calculator. I'm going to hit mode. When I hit mode, which is right next to that second button, I see that currently my calculator is in radian mode, which is fine because I need both answers. I just want to be aware of what mode my calculator is in. So I'm going to hit second cosine, and you see that I get that inverse cosine value right there of a -0.4531. Enter. And that's going to give us an estimated value of 2.0410 radians. Now we need a degree answer. So what I'm going to do is I'm going to hit mode. And I'm going to arrow over. I'm going to highlight degree. I'm going to hit enter. That's going to change my calculator from radian mode to degree mode. I go back to my home screen, so I hit second mode for quit. Hit second, enter, and all that did was recreate that exact same problem I just did, so I don't have to retype anything. I hit enter again, and it's giving me the equivalent measure in degrees. So I have two answers, 2.04110 radians and 116.9 degrees. Just like with the inverse trig from the unit circle, we give the radian and the degree answers. So I went second tangent, so I'm looking for my tangent, and I've got 0.9904, hit enter. Our calculator is in degree mode, so this is why it's really important that you are aware of what mode you are in. Oh, we didn't need to go that far. 44.7 degrees. Now I'm going to go to my mode and I'm going to switch it to radians. I quit out of that screen, hit second mode. I want that exact same problem again, so second enter. Hit enter again, and that's going to be about 0.7806 radians. All right, go ahead and hit pause, and I want you to do the last one on your own. All right, did you get something weird? When you hit second sine of 4, you got an error message. Even if I change the mode to degrees, because I was in radians, it's still going to give me an error message. This is not possible. Remember, our values are always going to be based on the unit circle. And if we look at our unit circle, the sine value is the y value. As I go around, this is a sine value of 0 because I haven't moved up any. I get larger, 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 larger. I max out at 1. Once I hit 1, I start coming back down. And then I go all the way down to a -1, and then I start coming back up. So when we're looking at sine values have to be between 0 and 1. That's actually going to be true for cosine values as well. Not true for tangent values, but your cosine and your sine is never going to be larger than 1 because 1 is the largest value that you can go right, the largest value you can go up, left, and down. All right, almost done here. Use inverse trig to solve for your Sohcahtoa problems. We want to find our angle measure. That's why we're using our inverse trig. When we do this, it's important to know how your pieces are related. This side is opposite. This side is adjacent. This is our hypotenuse. So we're given the adjacent and the hypotenuse piece, which means we're going to be using cosine of theta. Cosine of theta is adjacent over hypotenuse. In this case, the adjacent side is 15. The hypotenuse is 27. So our angle is the inverse cosine of that ratio. We're back at our calculator. So I'm going to hit second cosine of 15 divided by 27. I hit enter. And we've got 56. I don't even know what that answer is. I just hit mode, and that answer is actually in degrees. So we have our answer in degrees. Let's switch that to radians. Quit. Second enter to recreate that. So our two answers here is that our angle is going to be about 56.3 degrees, or it's going to be about 0.9818 radians. Last one, a crane has a 200-foot arm whose lower end is 5 feet off the ground. The arm has to reach the top of a building that's 130 feet high. At what angle should the arm be set? So on your test, it's going to be important that you're able to read these problems and draw a picture. So we have a crane. This is going to be my crane, and it's going to have an arm coming off of it. That crane has a 200-foot arm, and it's reaching the top of a building. Well, that top of the building, this whole building itself, it says is 130 feet tall. It also says that the lower end of the crane is 5 feet off the ground. So it's saying from here to here is 5 feet. So we're going to be creating a triangle right here. This is going to be our right angle, and we want to find out what angle should the arm be set at. So we're solving for this angle. The whole building is 130. This part is 5, which is going to make this 125. We look here, we are given the hypotenuse, and we are given the opposite side. And that's going to give us our sine. So sine of the angle is opposite over hypotenuse. In this case, that's 125 over 200. Don't worry about simplifying this fraction. Your calculator is going to be doing the work for you. So our theta is equal to the inverse sine of this ratio. What I want you to do is I want you to hit pause and find those two missing angle values in your calculator. Go ahead and press play when you're ready to check. All right, let's see how you did. You should have ended up with 38.7 degrees and 0.6751 radians. For your inverse trig, you have to be able to find the values from a unit circle. You also need to be able to use your calculator to solve for those missing angles. And that is the end of this video.